Okay, so we're looking at electrochemistry today, and electrochemistry has everything to do with chemical reactions where electrons are transferred. So electron chemistry or electrochemistry. And from grade 11, we have already introduced you to redox reactions. Some of us can't remember that name. So that means that we have to revise it again. And in grade 11, we spoke about oxidation and reduction. Now, basically, oxidation, as you can see here, is the loss of electrons. An easy way to remember it is the vowel O, also found in the word loss of electrons. And reduction will be the gain of electrons. Now, oxidation and reduction, therefore, is a transfer of electrons. And they occur at the same time. We also know that if you have electrodes where oxidation and reduction occur, the electrode where oxidation happens is called the anode. An easy way to remember it is that both of these words start with a vowel. And reduction occurs at the cathode. Both of them start with a consonant, so easy to remember. Oxidation here is a reaction where we see that electrons are emitted. And then once again, reduction is where electrons are gained. Now what's difficult about this concept is we understand gaining something as a gain and not as being reduced. So remember, when you gain negativity, imagine in life, if you absorb negativity, it reduces you as a person. So reduction is actually when you gain electrons. And another easy way to remember reduction is the fact that when your oxidation number decreases or reduces, reduction has occurred. When your oxidation number increases, oxidation has occurred. There are a couple of basic rules that we need to revise when we do oxidation and reduction, and these rules are also from your grade 11 textbook. I'll just highlight a couple of them. One, for example, is the fact that hydrogen normally has an oxidation number of +1. Now, there are exceptions to these rules. For example, if hydrogen is attached to a metal like sodium, a metal hydride, then it doesn't have an oxidation number of +1. I'm not going to go through all of those rules again. They are summarized at the top of page 409, but we will discuss the most important ones as it pertains to this example. In the past also you've noticed that when we write down charges, for example with hydrogen, we said the charge is 1 and then the plus. So that's how we distinguish between charges and oxidation numbers. Oxidation numbers, we write the sign, the plus or the minus first, and then the number, like this, for hydrogen +1. Another one to remember is oxygen. Oxygen has a charge of 2 minus. It has an oxidation number of plus, I'm lying, it has an oxidation number of -2. So as you can see here, it looks like the charges have something to do with the oxidation number, but that's where we make a mistake. Oxidation number is actually this hypothetical number that is allocated to single atoms in a substance. It's a way that scientists can understand where electrons are transferred and where they are not transferred. So if we look at this chemical equation here, it is currently balanced. I'm going to assign oxidation numbers to each of these atoms. Firstly, if we look at copper oxide, we know that oxygen has an oxidation number of -2, which means that in this neutral compound, copper must have an oxidation number of +2. If we look at NH3, we know that hydrogen has an oxidation number of +1. Because we have 3 hydrogens, it means that nitrogen needs to be -3 in terms of its oxidation number, so that we have a neutral compound here, and the oxidation numbers basically give us a 0 total. If we go over to the other side, one of your rules also from grade 11 was that an element that is not bonded to other elements, the oxidation number here is 0. Regardless of the 3 in front of it, doesn't matter. Same will apply here to nitrogen or N2. It will also have an oxidation number of 0. And when we look at 2H2O, remember hydrogen has an oxidation number of +1 and oxygen -2. This balances because we have 2 hydrogens. So +2, -2, 0. Now, when I quickly look at this balanced chemical equation, I also see that the oxygen on the left-hand side the oxidation number -2, on the right hand side -2, nothing has happened to the oxygen. If I look at my hydrogen, on the left hand side +1, on the right hand side +1, which means no electrons were transferred. Therefore, we only have two other atoms or elements here available, copper and nitrogen. So if we look at copper over here, copper went from an oxidation number of +2 to an oxidation number of 0. If the oxidation number reduces, we know that this is reduction. When we now look at nitrogen, we see that nitrogen used to be -3 and now it is 0. And this, of course, has to be oxidation, because the only way, if we transfer electrons, that we can move from -3 to 0 is if we release 3 negatives. So we see that this is oxidation. If we now go and we write down the oxidation half reaction, I've abbreviated it as OHR. You are not allowed to do that in tests or exams, but just to save space, of course. OHR, we have the NH3. We know that this nitrogen over here is going to become N2, so I'm focusing on the nitrogen, and I know that the nitrogen should have a charge. And if you look at it, it used to be N3+. I'm lying, it's not N3+, N3-. Yes? And it became N2. So no charge over here. So what has happened here? It has released 3 electrons. That is my oxidation half reaction. If I look at my reduction half reaction, remember here I had the 3 copper oxide that became 3 copper. We look at the oxidation numbers, we see it went from +2 to 0. Let's look at the charges. Remember, copper oxide is an ionic compound, which means a metal and a non-metal bonded. I know that this was Cu2+, that became Cu, and the only way that could happen would be if it absorbed electrons. Now, we're not too concerned about the electron balancing at the moment. What I want you to see here is that the oxidation half reaction, we see the release of electrons, and the reduction half reaction, we see the gain of electrons. If we were to go and balance this would have given us 3 electrons, and we can balance that, of course, when we're done. That's not the point, though, at the moment. We are looking at oxidation half reaction and reduction half reaction. Then, the last 2 points here. The substance that goes through reduction, can you see that copper oxide goes through reduction, is going to be our oxidizing agent. So we see here that the copper oxide is our oxidizing agent. And that makes our ammonia, NH3, our reducing agent.